And next speaker is Professor Antony Wood. And it's better for Ms. Clark to introduce his colleague in IIT.
It's a little interesting. We just had a little debate about who was going to introduce our next speaker. And we both wanted to introduce him. While actually it's somebody that doesn't need any introduction at all. I'm pretty sure you all know him as the most energetic guy in the world of tall buildings, who is also extremely passionate about what he does. And this is promoting tall buildings, and especially when it comes to sustainability. So it's an honor for the both of us to welcome to the stage, and I hope you will join me, Antony Wood.
Okay, natural ventilation in high-rise office buildings. This is the result of a guide that will be out July next year, co-authored by myself and one of my colleagues, a lady called Ruba Salib, although it's now been out for peer review initially for a whole panel of people around the world. So I'm going to tell you a little bit about this guide and some of the principles of natural ventilation behind it. So the agenda for the presentation. First of all, I just want to put this in the context of tall building trends and sustainability. Okay, two things that we all know, but here's some data. Number one, tall buildings are getting taller. That's the average height of the tallest buildings, 100 tallest buildings per year, plotted since 1930. So we can say that the average height of the 100 tallest buildings in the world has more than doubled in that period. And we all know that, you know, the world's tallest is getting taller, but actually to double the average height of the 100 tallest buildings is a pretty significant thing. Tall buildings are getting taller. There are more of them. These are CTBUH graphics, CTBUH research. That's a graph of the number of 200-meter tall buildings built every year since 1960. And actually the red shows the number of 300, so super tall buildings built. So you can see that we have been in and are still in an unprecedented period in mankind. We have never seen the amount of tall buildings that have been built and continue to be built in the last 10 years. And by the way, when we started predicting this about 3 years ago, we started to show a drop-off from about 2011 onwards because of the effects of the economic recession. We now no longer believe there will be a drop-off. Not only is it going to continue for the next 3 years, we believe it's going to continue after that as well, climbing in the way that we're seeing, because of the huge amount of projects that are coming online in Asia and predominantly China. However, the age of skyscrapers is at an end. It must now be considered an experimental building typology that has failed. That's a quote from 2005. And I think probably most people in this room and in this entire conference are pretty pro-tall buildings. And I would count myself amongst them, not surprisingly. But there's also a lot of bullshit around tall buildings. A lot of bullshit. And, you know, let me tell you that if anyone tells you that they're designing a carbon-neutral tall building or a sustainable tall building, they're actually talking bullshit. A tall building is not a sustainable building type, categorically. It costs more energy to put those materials up in the sky than it would in the low-rise realm. As a single building entity, a tall building is not a sustainable building type. It becomes sustainable when you consider the bigger picture, which is essentially beyond the single building. We have to do all that we can to reduce the energy consumption in tall buildings. And we've just seen that with Kathy's presentation. Incredible. But that doesn't make it a sustainable building in itself. And this, I hear it daily. Carbon neutral tall buildings. We are so far from carbon neutral that it's not really even worth mentioning the term yet. And even if you do mention the word carbon neutral, you're only talking about operating energy. You're not talking about the embodied energy in the materials to build the tall building in the first place. So we are kidding ourselves by saying and telling our clients and the public and other people that we are on the cusp of creating sustainable tall buildings in themselves. And there are very strong arguments around the world for why tall buildings are not sustainable. I have whole lists of them, which I'm not going to go through now. They only become sustainable when you put it in the bigger picture, and the bigger picture is about cities. It's about urbanization. It's about the fact that there are 200,000 people urbanizing on this planet every day. That means we as a species need to build a new city of 1 million people every week to cope with this urbanization. So where do these people go? Do they go in the American horizontal model for a city, or do they go in the vertical city? Do they go in the denser vertical city? And it's generally accepted that a denser vertical city can offer a more sustainable pattern in life, largely due to studies like this, which looks at albeit just in the realm of transport, but the relationship between transport and urban density. And at the one kind of sad, sorry end of the scale, we've got Houston, which is one of the most energy profligate cities in the world. And then on the other end, we've got Hong Kong. And why is Hong Kong one of the most sustainable places on the planet? Because of mass transport. Because you step outside your door and you have 6 or 7 options of moving around the city, none of which involve getting in a private automobile, or very few. So I wanted to put that in the context before I talked about natural ventilation, because I just feel frustrated that this greenwash and the kind of I just don't think we are helping ourselves by not being upfront. And the thing that's great about Kathy Yang's project, actually, that's the first time I've actually seen data of that nature put out there in the public realm. So the projects that are, kind of investing for better environmental performance, no one's releasing the data. So there's a whole problem in the industry. Do those wind turbines on the Bahrain World Centre work? On the Strata building in London, do they work? Does anyone know? Nobody knows. Or maybe the people that do know aren't releasing the data. Sorry, I'm going off on one. Okay, so, by the way, urbanization, tall buildings, is not just about developing countries. It's not just about the 200,000 people in countries like China, India, Brazil, Turkey. It's also about the West, because the changing social demographics mean that we need far more housing than we've ever needed. In my country of the UK, we need 200,000 new homes to be built every year to cope with the supply that's needed. Why is that? People are living longer. People don't like each other. Divorce rate is up. There's more single family housing is needed. So for those who think this is only an issue for the West, for the East, it's not. It's for the West as well. Okay, calm down. Right, natural ventilation, principles and strategies. So that's a bit of a precursor to say that despite that, we need to do the best that we can do to reduce any energy consumption in all buildings, and especially in tall buildings. And actually, Dennis Poon showed a figure this morning that 45% of energy consumption in tall buildings is, in the HVAC systems. I think in Kathy's building it was 53%. So we're talking 50% of the energy consumption going into heating and ventilation. I'm not going to go through this too much. Principles of natural ventilation. Natural ventilation usually falls into one of two categories, usually both at the same time. Wind-induced natural ventilation. So, ventilation is induced by a movement from positive to negative pressure. So wind-induced natural ventilation or buoyancy-induced natural ventilation. Heat rising. And the basic principles of natural ventilation, single-sided. You can naturally ventilate a single space if the depth from a window is 2.5 times the height of the building. If you cross-ventilate, you can go to 5 times the height of the building. And then we have the principles of stack ventilation. Hot air rising and bringing the cooler air through. I think it's worth saying that there are kind of 3 generic strategies for ventilation, for natural ventilation. Or 3 objectives, if you like. One is conditioning the environment, i.e. the temperature and the humidity of the air. A second strategy is conditioning the occupant, i.e. blowing air across them, which is not the same. That's to do with evaporation of the skin and various other things. And the third strategy is conditioning the building, the fabric. which usually translates into ventilative cooling, i.e. nocturnal cooling. What are the benefits of natural ventilation? By the way, this report focuses on case studies, and I'm going to show some case studies in a second. But the benefits. So I broke these down. Tangible benefits. Obvious one, reduced operating energy. So we want to cut the energy consumption in the building. Number 2, reduced embodied energy. That means, you know, if you are able to take out all the mechanical plant in the building and all the ductwork and all the rest of it, there's a huge saving in embodied energy. However, there's a question mark against that, because natural ventilation just doesn't happen with a whole other set of systems, which we're going to look at in a minute. Space savings. You know, if you're reducing the amount of MEP floors, then again, that can have a space saving. But there's a question mark against it. You take out the plant, potentially there's cost savings and reduced maintenance costs. And these are all very, very, very valid points. But actually what interests me the more is the less tangible aspects. For example, the impact on better indoor air quality than mechanical ventilation, because that impacts this, which is higher occupant productivity. And you know, we are only just beginning to realize this in the industry. And this is one of the problems with one of the barriers to sustainability. And it's getting better, but if you go to a client and say, I can save you 20% of your energy bill, the client will think, well, the energy cost of running my building is 0.5% of my total operational costs. But if you went to him and said, I can save 20% of your staff bill, that makes a bigger difference. And this is now becoming recognized, that you know, approaches in sustainability, in particular to the environment, making a better, greener, healthier environment, affects occupant productivity. And this is a little study that was done in 2004 that suggested that by creating a better environment, that impacted productivity by 8.5%, which was equivalent to a gain per employee of almost $4,000. Now, if you're timesing this across thousands and thousands of employees, that makes a difference. Let's look at some case studies. Oh, historically, I just wanted to say, historically, you know, buildings had a natural connection with their environment. That's why, if you look at historic buildings, they were relatively narrow floor plans. You wanted to ventilate the building, it involved the very arduous technical task of opening a window. And then even when they got deeper, they usually had a light and ventilation well at the middle. And then it kind of changed with this building, with this architecture. You know, the pinnacle of modern architecture, the modernism, the ability to divorce architecture from its environment because cheap energy. And in many respects, I think modernist architecture actually, you know, kind of has been the downside, especially of tall building architecture for 40, 50 years. That moment in time where we no longer had to consider the environment because we had the power, quite literally, to do whatever we wanted to. Okay, so let's start in 1997 with the Commerzbank. I'm sure you all know this building. By the way, this building was driven by a German regulation saying that you needed to be maximum 7 meters from a window. So we don't need to get too, you know, considerate altruistic about this. It was actually driven by legislation, a lot of it. But the ventilation strategy for this building, that doesn't work. Okay. The ventilation strategy for this building is very simple. The outside offices around the perimeter are ventilated directly from openable windows at the exterior, and then the interior offices are ventilated via a 12-story high central atrium being fed from a series of sky gardens which step up around the building. So you can see that in these diagrams here. You know, if we just go back to that, you can see that, so what we have is, the building is divided into 12-story villages, and within these 12-story villages are 3 sets of 4-story sub-villages, such that you always have a sky garden, but the sky garden steps around in 3 places on any 4-story level. And then there's a central atrium, which is capped every 12 stories. So you can see the ventilation strategy there. The outside buildings are ventilated directly from the facade, and this sky garden into the central atrium is pulling the ventilation from those inner offices. The corridor in the middle is mechanically ventilated. So there's the outside skin. It's actually a double skin. We're going to talk quite a bit about double skins in these cases. Oh, I forgot to say, the first 4 or 5 case studies that I'm showing are all from Germany, and they all employ double skin. And you know double skin? Once you've seen one, you've seen them all. Well, you haven't. You know, I'm going to show you 4 double skins which act completely differently. So this was one of the most simple ones, 97. You can just see there. There's an outside skin, and then the inside skin just hinges forward, just pivots forward. You can see that in the diagram on the right there. Oh, it is working. You can see that in the diagram on the right. So the air is actually fed through these fin devices here into the void, and then the inside leaf just pivots open. In extreme conditions, it's all closed off and mechanically ventilated. And by the way, I wanted to say that. I do not know of any naturally ventilated office building in existence in the world today. If anyone else does, please tell me. There are no naturally ventilated office buildings. This is not one. They are all hybrid buildings. Hybrid means it has the ability to be naturally ventilated or mechanically ventilated. Well, all those savings that I said about in the first place, the saving on space and cost and embodied energy and all the rest of it, is nonsense. Because if you don't trust in the natural ventilation systems, then you are perhaps reducing the plant, but you're not even doing that because it needs to be sized on the worst case, kind of scenario, which will be a hot day in summer. So even these buildings that are brave enough to really employ significant strategies for natural ventilation, they all have the mechanical plant ready to kick in on on the hottest day. So we're not really seeing again the pushing this to the point that it needs to, where we can create a 100% naturally ventilated tall office building. Okay, so and by the way, I'm meant to be talking about the report. So the report goes through the case study, it presents the case study, and then analyzes it in terms of strengths and weaknesses. So the strengths of this building, they move the cores to the outside to give flexibility of the interior space. Pretty radical approach. Most buildings have a central core. Use the sky gardens to permit efficient cross ventilation. In other words, you always have a sky garden on a windward side, because that central atrium is being fed by 3 sky gardens on 3 faces of the building. So whichever way the wind's blowing, it's always driving at least one of those sky gardens. It's using the central atrium as the stack effect to ventilate the offices, yet the 12-story segmentation prevents extreme stack effects, and the sky gardens are acting as solar collectors, thermal buffers for the space inside. Possible limitations: loss of space. Think about think about those sky gardens, the amount of space that those take up. I'm, developer's hat on now. The configuration doesn't specifically address the prevailing wind or sun. There could be uneven pressure distribution, ventilation in the offices then, and possible overheating of the double skin space or the thing. Okay, so next building, Deutsche Messe. So this is a few years later, a couple of years later. So this building, let me show you this slide. This building has a double skin facade. 1 story high. So this double skin facade is a zone at the edge of the building. The floor comes through on each floor. And basically what it is, it's a big horizontal duct all the way around the building. And in the place where the corridor comes across, the single-story void of the facade comes into a duct below the floor. So it is a continual horizontal duct all the way around the building. It's quite nicely designed. So air comes through the facade, through louvers in the facade, into this space, and individual occupants decide if they want more of that ventilation by basically opening these sliding doors to let more air into their space. There's a mechanical system in here, which you'll see through these vents. And if it's running in a mechanical mode, or part mechanical mode, the opening of those sliding doors automatically cuts off the mechanical flow, the mechanical supply of the ventilation. And the other nice thing about this tower is that it uses the stack effect in the circulation towers to exhaust the air. So we've only spoke about the supply coming in through the ventilation and then through the openable, slidable doors. But it's then drawn through the building and into one of these, into this tower. And that tower extends higher than the building and is drawn off through the stack effect acting in that circulation tower. So you see the vents on the outside of the building. And you know what, I'm going to speed up. But hey, there's a whole bunch of good things about this. You know, there's a whole bunch of good things about double skin facades. They protect from the noise and the elements. They temper the space. They do all this. But it's still 1,400 millimeters of non-usable space on the outside of the building. That's a hell of a lot of space. And also, you know, occupant understanding of the systems is pretty important for operation of that space. Deutsche Post, around the same time, again in Germany, a double skin facade, but a different double skin facade on the north and south side of the building. So on the south side of the building, where the solar gain is higher, you have a kind of shingled facade, where the air is coming in underneath these overlaps in the facade. And by the way, this is not a single story. This facade now is 9 stories high, so it's broken down into 9 stories. So another double skin facade, but working in a completely different way. The air is drawn into the facade differently on the north and south sides of the building. So this is the north side, where you'll see it's a flat facade. It's not shingled. It's not overlapping. This is back to the south side. So those glass horizontal flaps lift up there and can be controlled to let greater or lesser air into that tempered space and then being drawn into the offices. There's a section through. And then it's being extracted through these 9-story sky gardens, which are stacked up on top of each other at the center of the building, which are then in themselves naturally ventilated. So you can see there the 9-story sky gardens, which are using acting as big exhaust ducts, really. The next few examples, I just show you some things that are different. What I'm trying to show you is that there's lots of different strategies for naturally ventilating tall buildings, even with double skin. So the GSW tower in Berlin, that south-facing double skin facade, now the cool air is being drawn in from the other side of the building, and it's acting as one big stack effect. You know, so they're encouraging the sun to come into that space and bring the stack effect out through the top. And they even put okay, so there you see that. They then even put this wing roof on the top to attenuate the wind pressure, bringing the exhaust air up through the facade. RWE headquarters, a completely different approach again. Similar in the double skin facade and this fish detail of letting the air come through the kind of mullion arrangement. But then one panel is about air supply and the adjacent one is about air exhaust. So the first project I showed you was one big horizontal duct all around the outside. The second one was vertical ducts 9-story high. GSW's one big kind of solar chimney facade at the edge. This one's using a different strategy, each panel for supply and extract. Manitoba Hydro Place, again, has a completely different strategy. And this is interesting because this is in Winnipeg, you know, where it goes from -35 to +35. And one of the interesting things about Manitoba is that it uses a water feature in the building to humidify or dehumidify the air. And then you have this solar chimney, which is extracting the air again. Speeding up. Menara Umno, completely different. This one uses wing walls to encourage wind to come through. By the way, I heard that. I heard it. To encourage wind to come through, so it's ventilating the occupants directly. By the way, I just cannot see this building work. This building just cannot work. You know, it would have to have such a high ventilation rate that it's going to be flapping papers all over the show. So there's no way I think this building could work. So, so the report, back to the report. So the report goes through these case studies and then it draws out a number of considerations and then makes recommendations. And the considerations are things like, you know, there is no one solution. And by the way, I only showed you some of the case studies. This is another one in Central America. You know, it's about solutions that are appropriate to this context and climate. This is an important one. Thermal comfort standards. This is really quite important because we as a species have become so attuned to mechanical ventilation that a 1 or 2 temperature differential and we're like, oh, it's freezing cold or oh, it's boiling hot. You know, we've lost the ability to adapt to our environment. And studies have shown that in cases of natural ventilation, we become far more tolerant, which actually is something that we need as a true response to sustainability across a whole manner of things. So we need to change our attitude towards what's acceptable in tall buildings because we can do it as a species. So there's a whole bunch of other considerations, but you know, let me just move to the conclusions. Sorry, recommendations. So this report makes 40 recommendations, and some of them are quite simple, such as orient the building in line with the prevailing wind direction to maximize wind as a primary driving force. And some of them are quite, you know, detailed. Like when using thermal flues, it's recommended to extend the thermal flue beyond the roof level and fill the topmost part with a material that has a high thermal storage capacity so that the stack effect can still work on cold nights. So, you know, I only show a few of the recommendations there. Basically, you know, this presentation is saying, wait for the report. So it'll be out in July 2012. We have a deal with Taylor & Francis, so we're going to be publishing this widely on bookshelves around the world. I want to acknowledge many of my colleagues, some are in the room now, who have peer-reviewed this report and will be peer-reviewing it again before it goes for final publication. And this is my final slide. And I love this slide because there are two things, there are two advantages that tall buildings have. One we spoke about, they increase density as a response to climate change and sustainability. One, they increase urban density, which is vital. But this is the other one. This is a little testing rig for one structural connection in a tall building. That's the bit of the tall building. And in tall buildings, because of the scale of them, because of the investment, professional, time, financial, we are able to test things and incorporate things in an experimental way that we are not able to do in small buildings because there's just not the budget or whatever for it. And this is why tall buildings have the opportunity to show the way for the benefit of all buildings because of the investments in them. Thank you.
Thank you, Antony, for again a very passionate and inspirational presentation. By the way, this is just the output of one of the working groups of the Council on Tall Buildings and Urban Habitat. There is many. If you go onto the website or you come to us, we can tell you what working groups we have, and I think it's a great opportunity to share your knowledge and the insight to make the tall building world just a little bit better.